Okey-doke. Right, well, I'm into my first presentation, if nobody
Leave you
else
to it.
got anything. Leave me to it. So this presentation's a little bit split, where I'm going to do a bit to start with, and then Ed's going to step in a bit and talk about CUSF flights, and then we'll swap back to me, hopefully. Whoop. So this is a bit of a retrospective on what's happened over the last 10 years with UK or amateur high-altitude ballooning, to be honest. But I thought I'd step back even further in time to start with and just see where it's all evolved from. This has been put together, a lot of this has been put together by trawling emails and looking at, UKHAS group stuff and trying to work it out. If you think anything's wrong, either put your hand up or let me know later and we can sort of change some of the timings. Some of them surprised me, actually, when I was going through it, so there may be the odd error in here. Okay, so the very first amateur high-altitude balloon flight ever, as far as we know, was Imari 1, which is way back in 1967. I'd have been 13, so you can guess how long ago that was. Actually, it was on my 13th birthday, exactly on my 13th birthday flight. That's a picture of the transmitter. There are two frequencies being used, 2 meters and 70 centimeter beacons, about 10 milliwatts and 1 milliwatt respectively. And that was in Finland, and they actually got it back, so that was pretty good for a first flight. The next thing, I remember when I was about 13, 14, 15 or so, reading VHF Communications magazine, and there was in there at least a couple of flights in Germany called ARTOB, which is Amateur Radio Transponder on Balloon. And this was actually a linear transponder that they were going to put in an Oscar satellite, I think, which they flew as a balloon payload. And it took a segment of 70 centimeters and 100 kilohertz and translated it down to 2 meters. And you could hold a conversation via it. So it's pretty advanced, actually, for given it was sort of 1970. People walking on the moon, all of that. I don't know very much in between these times, but certainly in 1987, Bill Brown in the US started to do flights, and he's pretty well credited as the first sort of US flight. And as a whole, amateur high-altitude ballooning was pretty successful in the States and still is, from 1987 onwards. But it's not really until we got to 2005 did we start to do flights in the UK. And you sort of have to think, well, why was that? We'll come on to that as we go through. So the very first flight in the UK was James with Pegasus 1. And that was essentially a homebrew, I guess you'd call it like a mobile phone tracker, because it was essentially a GPS and a mobile phone connected together using a gumstick, which was a small Linux computer. And it just used to transmit its position. I think it also operated the cameras as well, did it? Yeah. James? Yeah. So there was a couple of cameras on board, and successful flight from sort of South Suffolk to Lincolnshire. Great. I don't know quite what you were using for prediction in those days, James, but good job it sort of landed.
University of Wyoming.
Oh, it was still Wyoming there, was there? Okay. Shortly afterwards, actually, you seemed to set up the high altitude channel, and people must have been talking about this. This is way before my time, like 6 months before my time, involvement. And then you flew Pegasus 2, and that one you lost. Just disappeared somewhere, never got it back. So don't really know exactly what happens. Guess it probably went to the North Sea. Then UKHAS seems to have been sort of started, at least the wiki was started, and there's mention of it in the IRC channels that UKHAS was set up. And then we flew Pegasus 3, or James did. And this was the first flight that actually had a radio transmitter on it, and I put in what was effectively a rocketry transmitter into it, and we flew it. And it became very evident that it was strong enough to support data over that transmission. It was a very strong signal for most of the flight. I think it even got to the landing spot before you guys, but so it was pretty good. And that's really what we realised, I think, at that point, that we needed some form of radio link for it to be at least a non-concerning flight, because before you just launched them, you knew where you'd launched them, and you didn't know where they were going to land until they landed, effectively, and then they reconnected to the mobile phone network if they did at all. So really, radio was became an essential part of flying out high altitude balloons. Well, I think it is anyway. Lawrence says, Lawrence, you launched your first flight the same day.
I did.
Yeah. I can't remember that, but
phone tracker.
right.
So very similar to Pegasus 1, but with AVR micro rather than the
Right.
6.
Right. Okay. But yeah, so we were launching a couple of flights, and so we'd done pretty well. The next flight on from that was Nova 1. Ed will talk about that in a tick. But that carried a radio transmitter, and on that system, it was one I put together, and on there we were using what was effectively packet radio. It wasn't APRS, but it was packet radio. And we really just wanted to test to see whether 10 milliwatts on 70 centimetres was going to be enough for packet radio. And sort of deemed it wasn't. It worked, but it really was on the limits of its sort of range when we used it. So next day we launched IHAB2, according to the thing. It seemed to be like Saturday and then the Sunday. Don't know why, but we did. About the same time, I sort of issued the first version of the burst calculator, which was quite useful because up till then we didn't really know how high to expect a balloon to go, other than what were the standard data given to you by the manufacturers. So burst calculator sort of allows you to sort of like play what-if scenarios with burst altitude and fill and descent rates, that sort of thing. And then we had UKHAS 1, which was a flight where we put a train of stuff together. Whoa! Here we go. We put a load of stuff together. Here's the pictures too. So that's my first payload there. That's the first thing I did, and that was, I guess, what sort of early on in 2007, February 2007. And it was a train of about 4 or 5 different payloads tied together. Pretty successful flight, so we got it back. That's what I deem success most of the time. Right, I'm going to hand over to Ed for a bit on CUSF. So how are you going to handle that, Ed? Hopefully just pushing a button. HDMI. Normally clicks. Oh, great.
Cool. I've only got about 10 minutes. I'm going to go through at the speed of light, if that's all right. So this was Nova 1. It was a PIC-based flight computer and a radio system by Steve. And yeah, that was the 9th of December 2006. That predated me. That was just before term started. So I came up for Nova 2, which was the 19th of November 2006. Now for Nova 2, there's a launch picture, and then you get the sort of gateway drug picture of, Nova 2, because Nova 1 worked well, it was actually the first one to fly RTTY, I think, and that was 300 baud, just because you didn't know if it needed to be 50 or 600 or whatever, we just picked 300. And again, another PIC-based thing. We bought 4 really quite expensive Kodak digital cameras from Jessop's, and very carefully removed the mechanical shutter switches and soldered a MOSFET across the shutter switch to fake a button press, and did it all very non-destructively so that we could then put the buttons back together and take them back to Jessop's within the 14 days, because we were 18-year-old students and couldn't afford that kind of thing. And so when we let go of it, we let go of the thing, and it went across about 4 rugby pitches and only just cleared the top of the building, the other end. It basically was going up at about a 1 in 20. So we knew we weren't getting that back. This was before flight predictors and stuff. But we tracked it to about 500 kilometres out into the North Sea before we just gave up in disgust and went to the pub. Nova 3 was, I think, UKHAS 1, that blue payload you just saw. Yeah, so back then, prediction, I mean, there was this University of Wyoming thing, but it was a bit mysterious. It didn't tell you ascent rates or descent rates or anything. It just says, here's where it's going to go. So this was, again, pre the predictor. We found this was Wonderground, and this was the sort of map you could get from the jet stream at 300 millibars. I don't know if you can see, there's East Anglia and the Wash and stuff just overlaid. But basically, you'd have these sort of colour maps, and you'd say things like, well, you know, it's sort of a bit sort of blue-pink kind of over us, kind of going that way. So, yeah, I think we should launch, or no. It was not scientific, and we lost quite a few back in the day. Nova 4 was, so we're now 7th of March 2007, so a bit after UKHAS 1. We always wanted to do a raccoon. So this was our first foray into trying out some raccoon things. By modern standards, this was a slightly crazy payload, but anyway, so there it is. So what have we got? We've got these 3 tubes, each contain a parachute packed with an explosive charge at the bottom, so the parachutes could be mortared out. Should the parachutes have failed, we had this kind of polystyrene thing which would bring the whole lot down, you know, like a shuttlecock. The flight computer lived in the bottom. There were cameras mounted to catch the shot of the things. And in here, we had the very first ever raccoon. So the raccoon was actually, it was an idea we got from Steve. The raccoon sits on a sort of, this is just a silly overview thing, but the raccoon sits on a piston on the inside of the tube. So the gases coming out of the rocket motor, as well as just being a momentum exchange to push the rocket up, they actually push the piston up as well. You can kind of see it fills up that volume and shoves the thing out. And that worked. Oh yes, and we had explosive. It was actually in Nova 5 we had explosive links, because Nova 4, it didn't work, but we flew the same payload for Nova 5. Here's a video. Again, this was 4 months before the release of the first iPhone, so the video quality is a bit rubbish. But you can see that's testing at ears, I think, the rocket launching. It's just a bit of fun. And then launch video for that.
Bye-bye, my pretty.
Yep. This one. There we go. Right, where are we now? Oh yeah, and you know, standard vision on top. Again, this was before Canon cameras and CHDK, and we just get these sort of dodgy old things off eBay that you didn't want to spend more than 20 quid on, and some of them really didn't like the low pressures and low temperatures or anything. But you know, we were learning every flight. So that was, so we did 2 flights of that. The first one, we came down early, and the second one worked. Although the camera stopped working that we're looking up, which was annoying. So then there's a year gap from March 2007 to July 2008. What were we doing? Well, because we were quite convinced that we wanted to do raccoons by that point, we realised if we wanted to actually get, although I understand, you know, we might get a different story in one of the talks later, but we thought we needed quite a big rocket to get to 100 kilometres from 30 kilometres, which means we need a much bigger balloon. So we started having a look at building our own zero pressure balloons. This one we made by hand. We cut all the gauze individually, and then made a sort of crocodile jaw heat welding seam machine to put it all together. This thing, which was only about a sort of tenth of the size we need for an actual raccoon, took 4 of us about a week to put together. So then we tried to automate that by building a machine that would feed. There was a big seam welder here, which isn't actually, we don't actually have a picture of it completed, and we had to mothball it because we got kicked out of this lab for making a mess. But there was a machine with a roller there and a roller there, and it would get this balloon material and weld the seams together simultaneously by translating the welding head. And with that, we made all of these, just experimenting with different styles, with 2 people in one afternoon versus 4 people for a week for that one. Coming back to flights again, so July 2006, summer holiday, we also built, Fergus and I built the Badger 1 flight computer. It was an ARM-based microcontroller, had an SD card. We used to, and I think people should more, have memory on board the flight computers and actually log a lot more data, because you're actually fairly limited with the bandwidth you can send down over over the radio. But there's lots more interesting stuff you could log if you just wanted to log it on board. On the rear side, we had the Lesson IQ, which was the sort of pre-U-Block's favourite GPS, and we had this GSM modem. Because again, there wasn't a distributed listener or anything, and you still wanted a radio backup, because if you let go of your balloon, it was normally only you listening. And we got some sponsor shots and all the rest of it. And we used to get free helium from Bog, which was super helpful, you can imagine. One interesting thing about Nova 6 is it's actually the very birth of the distributed listener. So this is a thing from the IRC channel. James decided to see if he could hear our payload, which people didn't really do back then that much, but and was posting the strings into IRC. And then we sort of talked about automating this process of posting things. So James, over about 10 minutes, got an IRC robot to read the log from True TTY, which was the thing we used before FLDigi, pass out the flight computer strings and spit them into the high altitude 99 channel. And then a few days later, I think Alexei, Natrium42, managed to put them onto his webpage, which became the Space Near Us tracker. So that was Nova 6 was actually the first inklings of a distributed listener. Nova 7, we went for a dawn launch. It didn't work at all. Again, pre-CHDK cameras, the Premiere cameras, they really weren't very good. And all we got was a load of crap. And then this one slightly passable, slightly impressionistic sunrise thing, but it didn't work. That was the 25th of July 2008. So 4 days later, on the 29th, we tried again at dawn, this time with a camera from Doug Ellison. And that was again, dawn launch, 3 a.m. launch, calculated to get sunrise at the right time. And this time we nailed it. And you've probably seen this picture before, which was a composite of all the cameras from the photos from the CHDK camera put together. Nova 9 was 2 months later, 1st of December 2008, infamous teddy bears. And that started a fashion for sending cuddly things up, which refuses to die. But it was actually a very serious schools outreach project that we did. We went to a local school and we teach them about what it'd be like to survive in space, and we sort of hammed it up by saying teddies will die unless you make the right spacesuits for them, given what we taught them about conduction and convection and radiation and so on. And we put temperature probes in each of the teddy bears. And you can see there's a sort of 20 degrees Celsius span difference between effectiveness of the different suits and so on. So that was good fun. Nova 10 was 3 months later in March 2009. Henry, one of the COSF guys, had built a star tracker. And in order to test it, he needed the star tracker to be extremely still, because they only look at a fairly small part of the sky and they're trying to measure sort of a few arc seconds of rotation. So he needed something like less than 2 or 3 degrees per second rotation. And he also needed it to float once it got to about 28 kilometers. So it had sort of a good half an hour lingering in very still air just to pick up stuff. So we went about that in 2 ways. To stop the spinning round, this is the bottom of the payload turned up. We made these drapes out of parachute nylon, which would hang down and just try and damp out any rotation. And for the floating thing, again, this was how do you pronounce Hoyi, those balloons?
Hoyi. Oh, I always think Hoyi.
What is it?
Yeah. Hoyi.
Hoyi, okay, fine. This was the pre-Hoyi. So we tried to float a slightly more manual way. So what we did was we got one balloon which was just filled to be neutrally buoyant with the weight of the thing hanging underneath it, and another second lifting balloon, and you can see there's a little explosive link there. So the idea was the 2 balloons would haul the whole thing up to about 28 kilometers, then we'd blow that, and this would disappear off, and then the whole thing would just hang, lingering at 28 kilometers under to take its measurements. And here's a video of that launching. And I put this video in because you can actually see the drapes worked extremely well, because after you let go of a payload, it's normally spinning around. This thing was solid as a rock. It was also quite a lot. I put about 80 meters in for the distance just to get the pendulum oscillation angle low. There we go. So you can see, it's not spinning at all. It worked quite well. And that was for Henry's master's project. By about this time, we got generally the distributed listener was starting. Our tracking was better. We had this automatic antenna pointer thing set up so it could move in elevation and azimuth, and was just run by a computer backside, so we could just leave that to record stuff and it would automatically track it through the sky. So that was fairly routine. Novas 11 and 12, we were just working on some other stuff. We did a few commercial flights because people just want a disco ball in space, so they're happy to pay us for it. Pays for PCBs, fine. Nova 13 was a similar flight. It was one of those ones where I think we were doing something for the university, and they brought a sort of film crew and all the rest of it, and we were a bit borderline about launching. Oh, because we'd written the first predictor the previous year, so we had the predictor by that point. And we were a bit hesitant about launching, but TV crew was there, so we did it anyway, which was the origin of do not launch if you're not happy, because don't be pressured by TV crews, because it will end up in the sea. So that was the end of Badger 1, it ended up in the sea. Although 3 months later, someone found the Badger 1 flight computer for us, which is nice, after 3 months in the North Sea. So that was the end of that. And then we get into, after some work I was doing, we offered to test some parachutes for a Mars lander, which was a really big step up in terms of complexity and criticality and sort of safety of anything we'd done before. Because we were basically making a vehicle that would free fall from 28 kilometers to a point where it was at about the right ambient pressure for the surface of Mars, and would then deploy a parachute at Mach 0.9 in Mars-like conditions, just to recreate the opening forces, because the opening forces are heavily dependent on Mach number and other things. And so I did a whole talk about this in UKHAS 2011, 45 minutes about this whole project, which you can go and see if you want. But we did a series of flights to test various bits of it, including we made some new flight computers for it. So this was the Badger 2, and then the Badger Cubs, and there were several of these in the flight vehicle. All of them had uplinks. So we flew Nova 14, I think was the very first uplink flight in the UK. This is again up on the roof of the engineering department at Cambridge. And it worked really well. We got uplinks out to about 250 kilometers into the sea. So that was good. And then, again, you should watch that video I did talk I gave in 2011, but this is just a video from one of the test flights. It's a high-speed video of the thing falling away from Berlin, yanking the parachute out of a deployment bag, sort of post-burst chaos. It's 10 times slower than real life. And you can see the parachute just sort of yanked out, but not inflated at all or anything. But it's just quite a nice video, so I'm putting it in more or less to finish. And then, I'll let you see it for a second. I think you see the moon at some point, which is nice. And then as well as so I've only really talked about the balloon stuff, but we were also working on rockets quite a lot throughout the first 4 or 5 years. We were making some carbon fibre darts and looking at things we could launch. There's the moon, launching the balloon. And you can see that parachutes. So all this happens over about 3 seconds, 2.5 seconds, but it's just slowed down a lot. There's the parachute inflating. So yeah, there's a whole other story with rockets, but I gave a talk on that in 2012, which you can go and see if you want to do it. So that's the first half of CSF up to about 2011, and probably Adam can give the second half from 2011 to 2016 next year. Thank you.
Thank you. So really, I just wanted to pick up from that that earlier point in time. Obviously, the Nova flights span into this. I haven't really gone down to the flight level, apart from some sort of exceptional ones now. I just really wanted to go through some of the sort of like technological things that happened during that time. The first one is our first attempt at sending TV pictures. This was done using sort of like standard slow scan TV. Downside of this system is you actually have to have like a single receiver receiving stream. It can't assemble the picture from different sources. But it was pretty good. It worked for the time. It's subject to sort of like noise and other disturbances. It worked reasonably well. About just before the end of 2008, we set up, Space Near Tracker was sort of tracking system set up, started to use that, which was a big boon really. And then the predictor, according to me anyway, came along about the middle of 2009. Is that about?
We wrote it in 2008, but the web version was 2009.
Right. Playing around with latex floaters. The first ones that we did were, I think they were Totex 1500 balloons with a, it was a ping pong ball with a hole in it, I think. Did we do that, James? No. No? I can't remember now.
We hadn't got that far.
We hadn't.
Pinholes. Yeah.
With pinholes, yeah, okay. But it wasn't Ho-Yi balloons. It was just the old Totex ones. Then, according to me, our first round about the first Pico flight was the beginning of 2010. I think that's UED actually. Yeah. So that's launching that one. SSDV, according to me, mid 2010. Is that right? Anybody know? Phil, we're here. Yeah, about then. Okay, that's good. So that was a huge improvement on SSDV because you can assemble the picture from different receivers. So if, you haven't got one part of it, you can fill in with some from another receiver. So a really big improvement. By about, it seems a bit late actually, but by about the middle of 2011, with lots of people coming on board, and we thought it'd be a good idea to make sure that everybody who does come on board at least knows what experienced one of us thought was a good way of operating on sort of safety, from a safety point of view. So we put together some guidelines on that, put that up on the wiki. First conference, 2011, something like that. This flight was a bit of a surprise to us. Obviously, nothing to do with the UK. Forgot his name. Ron, yeah, on the west coast of the States, launched a balloon. The intention was to float across the US, but instead of doing that, it floated across the US, the Atlantic, and landed in the Med. So that took us all by surprise, I think. So that was a really interesting flight, and really aided or started, I think, fueled this sort of like go around the world on a small balloon. There's a batch of really good balloons, I think from about 2012, and a lot of us went for trying to get the UK or trying to get the world record on altitude to take it off the US. So this was the first time that we took the altitude record off the US guys who got it up to that point in time. Mick beat me in the end. I put B1 up because this sort of just really tells you the length of time that the development went over. So there's a year-long piece of development by Leo, resulting in a flight around the world, B64, and pretty amazing, really. That was on a bespoke balloon, right? That was made on its own. But what we've got is Laura. I guess is, how do you actually pronounce it? Anybody know? Laura.
I think it's
Laura. Okay. And PS46 in the Southern Hemisphere was another. This is probably amazing on the basis that it's actually a standard foil balloon. It's just an ordinary party balloon with an HF radio hanging off the bottom of it. How that's actually sort of been achieved, I don't really know, but another amazing flight sort of around the world. So this is just a quick reflection myself on what the way things sort of worked and ended up being. To start with, the reason we didn't do anything in the UK until sort of like 2005 was they really didn't have a way of reliably locating the system, the payload afterwards. So really that sort of hacker maker culture enabled James to put together one of the very first sort of trackers, and that sort of enabled the first flights. Up till then, there'd really been no way of doing it. Couldn't use the radio license because amateur radio license because it's not allowed in the UK. Then after we'd done the first couple of flights, it became clear that we needed a radio tracking. And we did that. Necessity made us then develop a radio system based on license-exempt transmitters. And I think it's probably true to say that because we went the license-exempt route, everything was low power, small size. The distributed listener sort of was our equivalent of APRS and allowed us to receive from different locations and put it together in order to assemble a flight path. It also allowed us to do SSDV as well, really. So the low power and this sort of maker culture to produce very small, very light payloads drove these sort of altitude records. So that we could, take the altitude records of the States and also enable pico flights. So we ended up doing flights around the world. So that's just my reflection on what I think the way things came together. Anybody got any questions? This is more or less the end of the slot. Any reflections? James, you remember? Sorry? What are some? I don't know, James. I think LoRa is very interesting. I think that will definitely become more and more dominant in what we do. It'll be interesting to see just sort of what the penetration is. I can't imagine it pushing out, the sort of ordinary receivers completely, because it's so easy to do that for like a basic system. So it certainly grow there. I don't know. There's lots of stuff that's still unknown. I mean, we had this ringing floating flights. So when you get floaters, they go up and down in the atmosphere, and we never really got to the bottom of that. Why that was? So there's whole areas to explore that we've never gone into. But there's as you can see, even just from the wealth of stuff that was done by ourselves and by CUSF, that there's an awful lot that's more to do. Don't think it'll ever end. Okay.
How low is low power?
Sorry?
When you say low power, how low?
Typically 10 milliwatts, which is what's all allowed under the sort of UK license exempt system. So all of our stuff in the UK is typically done under that. We can achieve like 700 kilometres using 10 milliwatts with the right system. So it's not really been a restriction. It's only ever a problem really when it sort of landed and we're trying to find it. If you don't know where it was. Any others?
Is the proprietary closed source of LoRa sort of seem to be a bit of an impediment to development?
Yeah, it's always something I don't particularly like about it. But yeah, I think it is an impediment because I don't. It would be really nice for somebody to do like dongle-based LoRa receiver.
It has been reverse engineered now. There's code
Has it?
on
Really?
it
Okay.
doesn't do the forward error correction. I think.
Right.
Yes.
Yeah, a bit of a nightmare to sort of get backwards, working out.
It shows you what you can do if someone wants to have a go at making an open version.
Yeah, that would be a good thing for somebody to do to dig into the proprietary stuff, work out how it works. Anything else, anybody? Right. Oop.